Well, g'day, Max here again. Welcome back to the shop. So today we're going to do something a bit different from the norm. We're going to be having a look at a Vevor magnetic base Rotabroach drill. So the box arrived in good condition. Only one little hole there. That's actually pretty good. So I'll get it out of the box and see what we're looking at. Well, that's pretty good for a start. Comes in. Well, I wonder if Vevor know how to make video cameras, because the ones that GoPro make are absolute crap. That film, well, the camera just turned itself off automatically. Practically a brand new GoPro 10. Absolute rubbish. I'll never buy another one. And I wouldn't recommend anyone buy one either. Alright, back to our job at hand. Well, what can I say? Well, if anything, I'll give them full marks for putting it in a, in a reasonable case. Everything's packaged in very well. Foam block to stop it flopping around, hold everything in place there. So let's get her out. Just as a comparison to packaging, this drill here, it's a different make. This is a mag-based drill. It just has a Rotabroach attachment in it. It's a dedicated mag-based drill, as it has the ejection slot there for a Morse taper drill shank. Whereas your standard Rotabroach drill does not. Going back to the case, this drill here comes in this whacking great steel case, which is an absolute prick of a thing to get in and out. Right, back to the job at hand. Okay, so straight out of the box, it takes a bit to impress me, and well, to be honest with you, yes, I am suitably impressed by what I see. Decent power cable. It's actually a thicker cable than this other drill I've got here. But we're not talking about that drill today. We're concentrating on this Vevor model here. Your operational handles that screw in. Check this out, both sides. If I can get the right angle of the dangle to get the screw started. There we go. Yeah, so you could have your control handles on either side, if you're left or right-handed. So that's a big thing, which a lot of other drills, not all drills have that feature. Let's start with the instructions they give you. Well, they appear to be a very well detailed set of instructions as far as power tool instructions go, from what I've seen. It's all fully in English. Tells you how to operate it, explains a bit of the operation of the magnet. As far as a lot of people don't realise, if you're magging down onto thin material, you're not going to get the same holding force as on, say, a thicker material. So it does actually say your minimum is 10 millimeters thick steel. If you're going to drill through thinner steel, you just stick it onto a heavier piece of plate that's clamped in between, and also can be clamped underneath. Yeah, there's some very valid warnings here. I'll just read one of them out. The magnetic base cannot operate with a full load continuously. Continuous operation will affect the lifetime of the magnet base, and the temperature of the magnetic seat will increase, so she'll get quite warm, leading to potential fire. Okay, well, when the magnetic base produces a high temperature, do not touch it. It will cause serious burns if touched. Turn the switch to the off position and pull the plug out of the power supply when the magnetic base is not in use. Well, that pretty well goes to most magnetic base tools. They will, get a little bit warm. Although I have used some, a big Bucks magnetic drill I used to use, and that never used to have a problem, but it was a huge thing. Had automatic power feed on it and everything. But yeah, it does give some good instructional material in there to those who have not used this type of tool before. So yeah, no, well done on a half decent set of instructions. So let's go and see what we're looking at here. So it comes with the coolant container for your annular cutters. So that has two locating pins and just sits over there. And your hose has to come into this port here, which plugs into there. Well, there's an issue straight away. If you're using the handles on this side, you're going to have some interference either way you put it. So what they should have done here, this fitting down here should have had a 90-degree elbow on it. Then it would have made it clear of the handles on this side. That's if you're using the coolant. Not everyone uses a coolant. Some people use a cutting oil. So that's one thing. That fitting just screws in. It's not a big job to change that over to an elbow. So no real issues there. So that's this push-in fitting here. Now if that was on a 90-degree, would be perfect. And maybe just 3 inches extra hose would be absolutely perfect. So the drill comes with 3 Allen keys, a 12mm annular cutter with its ejection pin, a 10mm drill bit, a drill chuck, the arbor for the drill chuck. It's a light duty drill chuck. So we'll see how this goes. Going by past experience, I'd probably change it out for a Jacobs eventually if this one packs it in. So it has the taper adapter. You've just got to clean any oil and grease residue out of the taper bore and the pin. This goes in, hold it with your hand, just give it one good tock with a copper hammer, and that will seat it in place. Then it can be used in the drill. The 3 Allen keys they give you, one of them is for the height, so you have your up and down travel, but you can also position the drill in a different location. Now when the drill's at maximum height, there's something they have overlooked. You have the capability to move this right up here. So the electrical cord is a bit, let's bend you up a bit. The electrical cord's not long enough when the drill is at its full height extent. So you will do some damage. So that's something you've got to be careful of, and it's something they should have considered. So, not impressed with that. You might have an adapter, you might have a drill bit in here, and you need to go up to full height on your rack travel. So they boo-booed there. The other Allen key they give you is for locking your tool in and out. And the other Allen key they give you, I don't know where it goes, what it fits. It doesn't seem to fit anything. I'm assuming it's for the adjustable gib strip here, but it's the wrong size Allen key. So they missed the boat on that one. So that's 3 points I've missed the boat on. The issue with this cord, the Allen key for adjusting the gib strips, and the issue with the coolant bottle getting tangled up with the handles because I've got a straight fitting here instead of an elbow. That's not a biggie. Allen key for the gib strip, that's not a biggie. The power cord issue is a biggie. Right. You should be able to take the tool to full extent. You still have slack in that cable. And see, this one has a nice elbow on the top. Both drills come from the same country. So when you're using these drills, when they're magged onto a horizontal or even an upside down position, you need to have a safety strap securing them in the event of a power failure or anything like that happens and the magnet becomes demagnetized. Now, with this Model 40H drill here, in their wisdom, all I've supplied is a bit of rope and one of these cable clips here, which it's garbage. They need to have a proper web sling. Now I'm pretty sure I noticed on one of their other drills they had a slot cut in the base for a web sling to go through. That is an absolute brilliant idea, and I do not know why either this model's before or after that, I don't know. But that's what it should have. That's what they've done on other models. This is just a total crap and no one's going to use it. So it's an issue. So we have two big issues, this cord and the power lead. Apart from that, I think we'll get her plugged in and see how she goes, and hopefully we don't find anything else I'm not happy with. The drill guides here, it runs on aluminium guides. Let's bring you in a bit closer. So I've degreased the tapered bore of the chuck and the taper of the adapter. Just sit it in. That's all it takes. Providing these tapers are machined correctly, that's all it takes. So to install our chuck, it's just like a Weldon style mount. You lock-in grub screws and has 2 flats on the adapter. Pushes it up home, fits in quite good. Do the screw up, just give a chuck a little bit of a wiggle when you do the screw up, and that will line up the flats on the chuck adapter to the grub screws here. Just tighten those down. Right, we'll get some power set up and a drill bit put in. Okay, I've got their standard chuck in and their supplied drill bit in this drill. The drill is advertised as having 160 millimeters of stroke. Well, that's fine there for drilling, but if I inadvertently come up to clear swath, I can only come up an extra 20 millimeters. We start stretching this cable. As I said before, this cable is way too short. So if you're not looking at that and you're looking down where you're supposed to be looking at your hole, you come up to clear the swath, it's going to be very easy to rip this cable out of this drill and damage up there. Okay, the drill chuck is a little bit piss wobbly. We'll show you here. So I separated the chuck off the adapter and they separated a lot easier than what they should have done. All it took was a bolt down the end because it is a hollow chuck. Held it in my hand, gave it a tock with a hammer and they came apart. A bit easier than what they should have come apart. So let's check this adapter. And I can tell you straight up, without an indicator, that's running about 2 to 3 thou, which is good. There's no problem there. When I set the chuck up, it's contacting on the bottom of the taper first, and it's wobbling at the top. So the tapers are mismatched. So either the adapter's ground on the wrong angle or the chuck is ground on the wrong angle. But there's a fair bit in that, and that's what's causing our wobble. Okay, so I played around with the chuck a bit. We just cleaned up the taper a bit on the adapter to see if, and we did achieve a better fit in the chuck, but the problem is the tapered bore inside the chuck is where the fault lies. So I had full intentions of drilling and tapping a bit of a grid pattern in this workbench here. I thought it's not advertised really for tapping, but I'll drill and tap some holes to see how it would go. Unfortunately, I thought I'd give the drill its best chance. I'll use one of my good quality high-end taps to do the job. But as you can see, that's just way too piss wobbly. There's way too much run out, and there's no way I'm going to risk this tap in this chuck. This is a $50 or $60 tap. Might have even been $70. It's not a cheap tap. So we'll end the drilling part here, as I deemed it untestable with this chuck. So let's try a Rotabroach. So when you run coolant on these Rotabroaches using your coolant tank, you have your hose from your coolant tank, plugs into this adapter here. I'm just going to turn the magnet on for a sec. So So this is your pusher. This will push your slug out. It also opens a valve inside to let the coolant through. So the pin goes up into the bore and you'll feel it spring and open a valve. When you're drilling with your Rotabroach, this comes down, contacts your work and springs up inside. What that does, opens the valve for your coolant. But on this one, I can blow through that now. I should not be able to blow through it until there's pressure to open up that valve inside. So the valve's leaking inside. So that's not a good thing. So that means you've got to, with a faulty valve, you've got to regulate your coolant, turn it off and on here. You shouldn't have to do that. It's automatically done with that valve inside, providing that valve seals. Let me demonstrate on another one. So on this one here, okay, all the coolant equipment is missing, but that's the port right there for the coolant. We're cutting oil, whatever you're using. I'll push the hose up to it and I can't blow through it. So unless I push this up and open that spring-loaded valve. As you can see. So the Model 40H Vevor drill here, with its 4 major faults, i.e. the short electrical cord, the unserviceable drill chuck, the straight coolant fitting that should have been an elbow, and the tie down strap. I really like this drill. What I love about it is the lightweight. It's got a really good magnet. Now this does take a while to heat up, so I might leave it turned on and we'll see how it goes. Actually, I'll leave it turned on when we do the Rotabroach test, which we're about to do now. So it says its capacity is 35 millimeters and they supply a 12 millimeter Rotabroach. I'll have a look through my collection and see if we've got something close to 35 millimeters. But yeah, I really like that you can put the handles on the other side. Alright, it is a bit louder, but yeah, we're earmuffs. So I'm not going to ask them for another chuck because they're going to send me the same thing. I might go and buy a chuck myself. I'll take it down to the electrical contractor that I use. I'll get them to lengthen this cord, because they did supply this drill at no cost to me for me to keep. So, and I will change this to a 90-degree fitting, and this will be a really good drill. I'll be happy to own it and use it. So let's get set up with the Rotabroach. Having said that, I don't know what other makes in the same class and price range as this. Not having used one, like I've never used cheap mag base or Rotabroach drills. I've always been more of the high-end ones of the very good quality. But yeah, it would be interesting to know. There's other makes around of similar price. I mean, this one here, swing you around. This is along the same lines, I think, as this with regards to quality. So, we don't know, but it is a much bigger drill. That's the beauty of this one, is it's lightweight. So, yeah, let's get a Rotabroach set up, see what it can do. Okay, I changed my mind. We're going to do one hole through this piece of steel. This is Bisalloy grade 80 steel. It's a high tensile steel. So I did want to start doing our grid pattern on the bench with this, but not with this drill chuck. But we'll try one hole through some Biz 80. We'll go through with a 1/4 inch pilot drill, and then we have a 21 30 seconds or 16.5 millimeter shank. We'll see if that chuck will grip this drill bit. And give it a go. I don't have any harder grades of bisalloy because that's the true test. Now, drilling bisalloy, you don't stop, you keep going. Especially the harder grades, as soon as you stop, they can work harden, and that's the end of it. The Biz 80 is generally not too bad, it's the higher grades. So let's try the bigger drill bit. You wouldn't have heard it probably, but the slight squeal at the end, that's what bisalloy does. The harder stuff will squeal all the way through. Even the chuck key doesn't fit the chuck very well. It's showing wear on it already. I've only used it once. I've got Jacob's chuck keys I've had since I was a first year apprentice that are still as good as the day they were new. Alright, let's try this bigger drill. Well, that went through that no problem whatsoever. Okay, we'll try a Rotabroach. That's one of the blue bisalloy chips, just from that hole there. That's our Rotabroach in. One thing I do love is this really easy adjustable slide to relocate the drill on the slide there. That's really, I like that, it works really nice. Okay, so this is the 12mm Vevor supplied Rotabroach going through bisalloy 80. I expect it's just standard high-speed steel. It's marked as high-speed steel, so let's see how it goes. No problem whatsoever. It even spat the slug out somewhere. Okay, so let's step up a size and we'll take it to its maximum. So these annular cutters, Rotabroach cutters, one thing where they really come into their own is drilling holes through things like, for example, a front end loader, the bucket, the lip of the bucket on the front. Sometimes the cutting edges get replaced and modified, and the lip of the bucket, which is made out of wear plate, has to be re-drilled to suit the hole centers of the new cutting edges. So, and that's where these really come into their own. You can't, well, I haven't found anything that beats them. You really struggle with the drill bit, but these, no, I've had no problem whatsoever. I haven't done one in a long time, but yeah, these were the best thing to get through them. Even old mate over in Queensland uses one. Here's a picture of him now, which he let me use. And as you can see, that material he's dealing with there, that's the same as this, Biz 80. I'm pretty sure he used Biz 80 on those moldboards. If not, it will be something very similar. So, now, in all fairness to the drill here, we do have a brand new 40mm Rotabroach. I don't have a 35mm. Now, if you're actually using this to drill holes and not just a demonstration, I have a 40mm one here, which is still reasonable. It's not brand new, so we're going to test the drill with this 40mm used Rotabroach in Bisalloy 80 grade plate. I feel using a brand new one would just make it too easy, and in a real life situation, if you're drilling, say, for holes in wear plate or a bucket lip for cutting edges or something similar, yeah, your first hole's going to be, might be with a brand new one, but by the time you get to the 12th hole, you're going to be dealing with this. So this is what we're going to try with this drill. Let me get it set up. Get our pin. And as I said before, just give it a little wiggle to make sure the locking grub screw pulls up square onto the flat. Okay, so just with regards, before we start drilling, to the temperature of the magnet, as they mention that in the instruction book here, that it can get quite hot. Well, that's really the temp that is. That's nice. There's nothing hot about it, and this has been on for 3/4 of an hour. Generally, you drill your hole, you swap, you turn your magnet off, you move positions. But that's not hot at all. Just put a temp gun on it. 18.6, 18.7 degrees C. And in bananas, 66.5. And our bench in bananas, 50 degrees C, 10 degrees. So yeah, nothing hot about it at all. It's just mildly warm. Lucky my wife's not here watching this. Should say, well, the operator's pretty hot. Oh, I wonder. Right, so we'll get our 40mm hole done now. Same material, 80 Bisalloy. Well, I'll say that cutter's probably a bit too blunt, so we're going to have to try our new one. As I said, this is pretty tough stuff, but the drill itself didn't bog down too much at all. The drill handled that quite well. So let's swap this cutter out and go again. Right, let's try that again. We've got a new cutter in. Well, we've got a great bird's nest. Nice hole. I don't know how that Rotabroach fared. I have to take a closer look at that, but this is high tensile Biz 80 plate, so we're drilling a bigger diameter than what the drill's rated for. So I actually felt that went through not too bad considering the size of the drill and all of that. It's only about a 1/4 inch plate, so if it was a thicker plate it wouldn't have handled it. So unfortunately we didn't have a 35mm diameter Rotabroach. So yeah. So these are our holes. That's the 40mm one we've just done. That was the one with the supplied 10mm drill bit, and that was the one with the supplied, that was the one with the supplied 12mm annular cutter. That's the one we drilled with the 16.5mm drill bit. Yeah, that's our 40mm one which we've just done. That's the blunt 40mm where we did previously, and that's where the magnet moved. We're putting that much pressure on it, but actually the magnet actually moved, and that was a lot of pressure I was putting on it, and I think the drill handled that quite well. And of course there's our Bisaloy bird's nest. This cutter we were using is high-speed steel cobalt cutter, so that's that was a X-Torque cutter, M35 cobalt steel. The cutter's still got a nice edge on it. The cutter stood up well. So let's try the centre punch test. Just on the bench, which is mild steel, so it'll be probably 250 grade plate. Certainly didn't do me centre punch any favours. I'm wondering if this isn't a higher grade of Bisaloy than 80. This could even be a bit of 320, as being it's only like 1/4 inch, 6mm thick. I'd say it's possible it's a bit of scrap cut off for a wear strip. let's try the section in here where the cutter tried to cut it before. Yeah, that's quite hard in there. So that other cutter that we first tried, it felt sharp, but it was obviously not quite sharp enough. And as I said before, this stuff will work hard. And had we been running the flood coolant through the little tank, we may have got away with it a bit better, as the coolant is always at the cutting edges of the cutter. So, but there you have it. It's quite a good drill to get through this material here. Well, I think that's as fair and honest review I can give our Vevor number 40H magnetic based Rotabroach drill. There you go. Like I said, it's done everything that we've asked it to do, and it's done it quite well. People not going to be drilling through Bisaloy every day of the week, and that was an oversized Rotabroach to what the machine was designed to run. It got the hole done. On its smaller size Rotabroaches, no problem whatsoever. And I really like the weight of it, or the lack of weight. The magnet was good, didn't get hot. Even though the drill might have been a little bit noisy, but I opened the workshop door and that seemed to settle. A little noise went outside. So yeah, end of the day, as I've just said, would I buy this? And as I've previously mentioned, you're not going to be able to go and take a similar model home to try out to get a good comparison. So I would buy this, but bear in mind the four faults the main faults are the cable, the drill chuck, the little coolant fitting, which should be an elbow, and the coolant valve up inside, which isn't sealing. But the main structure of the machine seems pretty solid, which is the main thing. The cable can be lengthened, a fitting can be changed. I don't know how you get on pulling it apart to have a look at what's going inside with the leaky coolant thing, or you just swap it out for them for warranty, and hopefully, or hope you get one that didn't, with a valve that was shutting off. It could just be a matter of back blowing with an airline. It could be some crap stuck in it from manufacture. Who knows? I found the variable speed seemed to be alright. Seemed to work as well as any other variable speed tool that I've used. Of course, on slower revs, you don't get the same torque with variable speed on a tool like this as you do with the higher RPMs. So anyway, that's it in a nutshell. The Vevor 40H drill. Anyway, thanks for watching. Cheers, and we will return to our regular program the next video.